You're welcome back to this channel. Today we're going to be talking about sword and some evaluations, expressions, and how we can handle them mathematically. First of all, why sword? How do we come about the name sword? Now, from elementary mathematics, we know about natural number, and we represent them by n. We also have integers, we represent them by z, so on and so forth. We talk about whole numbers. We're going to deal with this when we come to talk about the vocabulary of mathematics. But there is a particular set of numbers we want to talk about today that will lead us to what sword is. Now, we call them rational numbers. Rational numbers. Numbers that can be expressed as a fraction of two integers. What do I mean? If a is an integer and also b is an integer, if you can express that number in this form, a all over b, then we say that number is what? Rational. That means they can belong to this set, z. They are rational. But if you can't express a number in this form, then that number is irrational. Now, numbers like root 2, they are irrational. Now, reoccurring decimals and then terminating decimals are rational numbers. What do I mean by reoccurring decimals and terminating decimals? Now, if you say decimal like this, 0.3 is rational. It's reoccurring in the sense that maybe 3, 3, 3, 3, which we can represent as 0.3 dot to express that this is reoccurring. They are rational. But once they are not terminating and they are not reoccurring, they are irrational numbers. Numbers like pi, they are not rational numbers. So any rational number that has the radical sign this is now called a sword. Is now called a sword. So we are going to deal with sword. We talk about numbers, integers, how integers become rational numbers. When they can be expressed in this form, they are rational. Number one, they are terminating. Or they reoccur. They reoccur, they terminate, they are rational. Otherwise, irrational. Irrational numbers. Before we continue on going into the application of sword and how we evaluate sword, you need to know some basic steps. You need to know what is this. Difference of two squares difference of two squares. When you have minus b squared, that's you have an integer squared and maybe another integer squared. We are representing them with these letters. How can you expand them? They are actually b, then a plus b. Upon expansion, you will see that you have a squared, then plus ab minus ab, then minus b squared, and then this goes. Now, for you to evaluate sword easily, you must come to understand this very well. It's necessary and sufficient in Secondly, you talk about conjugate of two numbers. When you have, similarly, when you have x plus y, the conjugate of this plus this is actually this and this. Very important, very important, very important. Conjugate. Very, very, very important. So we go simply into addition of sod. So if you have a sod a root x, and you have another one b root y, you can add them as a root x plus b root y. So subsequently, if you have other sort like c, also root x, and then d root y, then a root x plus c root x is going to give you a plus c root x. Now, for simplicity, we can say it plus or minus. So if you have a root x plus or minus c root x is actually equal to a plus c or a minus c root x. For example, if you have 2 root 2 plus 3 root 2 is actually equal to 2 plus 3 root 2, which is equal to 5 root 2. And if it is subtraction, you just have 2 root 2 minus 3 root 2. Now I have 2 minus 3 root 2, which is minus 1 root 2 minus root 2. We go to sod multiplication. Multiplication of sod. Similarly, you can have a root x comma b root y multiplying each other. You will now have a root x multiplied by b root y. You have a multiplied by b, then you have root x multiplied by root y. Very simple. Example. Similarly, you have 2 root 3 multiplied by 3 root 3. So you have 2 multiplied by 3, and then you have root 3 multiplied by root 3. Very simple. You evaluate this to the final answer. So we continue. You can evaluate sod. Now, there is different representation of sod. You can represent sod in index form. What do I mean? Let's use our A. In sod form, you can represent it as a raised to the power 1 over 2. You can represent it as this. That's in index form. And now, if you have them multiplying each other, so you can get a raised to the power 1 over 2 multiplied by a raised to the power 1 over 2. And if you're familiar with indices, you add the powers. We're going to do a lecture on that. And then you have a 1 over 2 plus 1 over 2. So you will now have a raised to the power 1, which is just a. So looking at it critically, you will look at it this way. So if I have a multiplied by a, is the same thing as having a all squared, is the same thing as just writing a. From our expansion previously, you can see that when you have a surd multiplying itself, it is just that particular number in the root. So we now go to the use of conjugate in solving surd. Remember, we said conjugate of a surd. If you have a surd x and then you have a plus y root b, then their conjugate, the conjugate will just be x root a minus y root b. Bear in mind what conjugate is all about, and then what difference of two squares is all about. You will discover why you actually need the conjugate in solving surd. For example, you have 2 root 3 multiplying 4 root 3. We have 2 times 4, then we have root 3 times root 3. What do we have? 8. Then from what we have learned here, you know that this is just going to give you 3. As simple as that. Then this will give you 24. Now, if you want to multiply something like this, we have 2 surd, this and this, multiplying each other. So you have a root x multiplying c root x. You still have the same plus a root x multiplying b root y. Then you go to this one, you have minus b root y multiplying c root x. Similarly, you have minus b root y multiplying b root y. Or you can do it this way. This one multiplying all this c root x plus b root y, and then you have minus b root y into c root x plus b root y. They are the same. Example, you have 2 root 2 minus 3 root 3 multiplying 4 root 2 plus 2 root 6. So what do we have? We have this multiply this. You have 2 root 2 multiply 4 root 2 plus 2 root 2 multiplying 2 root 6. You have minus 3 root 3 multiplying 4 root 2 minus 3 root 3 multiplying 2 root 6. So you can expand. You have this 8, this times root 2. This 4. So you have root 2 times 6. minus 12 root 6 minus 6 root 3 times 6. And then you evaluate simply. Before we go to multiplying a sword by its conjugate, there are some representation of sword. When you have a sword in this form, a all over b is the same thing as root a all over root b. Similarly, if you have a multiplied by b, then it's the same thing as root a multiplied by root b. So let's multiply a sword by its conjugate. You have 5 minus root 2. We all, from what we have learned, the conjugate is going to be 5 plus root 2. Looking at this, upon expansion, you have 5 times 5 plus 5 root 2 minus 5 root 2 minus root 2 squared. So if you look at this, you see you have 5 squared also. So this will go with this. See, now I have root 2 squared. Now it's looking like difference of 2 squared. So you just have 25 minus 2 from what we learned. Since root 2 is equals to 42, so you have this, which is now 23. Now when you multiply a sword by its conjugate, you're going to have a number. The sword will be eliminated. Now if you look at it from your expansion, you just see that you just need to square this, and you get this using the principle of difference of two squares. Now we talk about rationalization of sword. How can you rationalize a sword? In sword, we don't allow the sword in the denominator. What do I mean? Root a. Not good. You have to do what we call rationalizing. That's multiplying by the denominator. So you do this, so that your answer will now be root a. Then here you just have, so you have root a upon a, or 1 over a root a. Example, you have 1 over root 2 can be expressed as root 2 multiplied by root 2 upon root 2. You have root 2 all over squared, which is just root 2 all over 2, or 1 over 2 root 2. In like manner, if you have 3 all over 2 root 2 plus 2 root 3. We say we don't want to see the sword in the denominator. You rationalize, so you have what? 2 root 2 minus 2 root 3 all over 2 root 2 minus 2 root 3. Now we know this is the conjugate, and if you look at it, actually this is equal to 1. So it's just as if you're multiplying the same problem with 1. It changes nothing. So we are going to deal with this. Since we know if we multiply a sword with the conjugate, we're going to get a number, so which means we are going to eliminate the sword in the denominator. Simple. So you have 3 into 2 root 2 minus 2 root 3. Similarly, we can do it. If you look at it, it's just as if you have a difference of 2 squares. So you can just go ahead and multiply this and this minus this and this. Is the same thing. But for the sake of this video, we are going to do it the normal way. We have 2 root 2, 2 root 2. Again, you have minus 2 root 2 multiply 2 root 3. Then you have plus 2 root 2 multiply 2 root 3. Then you have minus 2 root 2 and then multiplying 2 root 2. So you have 6 root 2 multiplied by 6 root 3 upon this multiplied by this, you have 4. This multiplied by this, you have 2. This will go. Then we have this multiplied by this, you have minus 4. This multiplied by this, we have 2. No? It's 3. So we have 3. So we have 6 root 2 minus 6 root 3 upon, here you have 8, while here you have 12. The difference is minus 4. Then you have 6 here into root 2 minus root 3 all over negative 4. So you can have minus 3 upon 2 root 2 minus root 3. Very simple. We have eliminated surd in their denominator, and that's that about that. Looking at this equilateral triangle, what do we say is equilateral triangle? You all know it. You have 60 all around, 60 degrees, 60 degrees, and then 60 degrees. To split this into 2 equal half, then we have 30 degrees, 30 degrees. Then we have 2 centimeter here. We have 2 centimeter here. So that means we are going to have 2 centimeter here also, 2 centimeter here. So dividing it into 2 equal half, then we have 1 centimeter and 1 centimeter here. So we can just include that's this equilateral triangle. Similarly, we can have a right angle triangle where you have 90 degrees here, and then here you have 45 degrees. So since angle in a triangle make up 180, so this side will also be degrees as well. So if we have 1 here, 1 here, we are left with this angle, so we can use Pythagoras theorem. From Pythagoras theorem, we know that this side of the angle, let's mark it x, we can get it like this: 1 squared plus 1 squared. So x squared is equal to 2. So x is just square root of 2. We can apply surd in this form. So here we have root 2. Similarly, coming to look at this angle also, this is the hypotenuse side. So we are going to get from Pythagoras theorem 2 squared will be equal to this side. Let's mark it h. So it's equal to h squared plus 1 squared. So we are going to take this to the other side. We have 2 squared minus 1 squared is equal to h squared. So we have 4 minus 1 h squared. 3 is equal to h squared. So we have root 3 is equal to h. From this, we assume we know what is Pythagoras theorem, which says if you have the hypotenuse side and it's a right angle triangle, just like this ones, then the square of the hypotenuse side should be equal to the square of the sum when you square the 2 other sides. Then we also have cosine of an angle, sine of an angle, and tangent of an angle. The tangent of an angle, we have the cosine like this. Then we have sine of an angle. So we can call it tan. We can call this cosine, and then we can call this sine. Now we can say that for the tangent, we have the opposite for short, then we have the adjacent. For cos, we have adjacent over hypotenuse from trigonometry. Then opposite is just, then sine, we have opposite over hypotenuse. So if we have this angle, this is opposite, the hypotenuse is always the longest side, then this is the adjacent. So we use it to get sine 30. We just have 30 opposite hypotenuse 1 over 2, 0.5. Cos 30 adjacent hypotenuse. Adjacent over hypotenuse, so we have root 3 all over 2. Then for tan 30, we have tan opposite all over what? Adjacent. So you have 1 all over root 3. Since we don't want root 3 in the denominator, this is equal to 1 all over root 3 times root 3 all over root 3. So this is 3 all over 3. So in the same vein, if you want to get tan 45, tan opposite all over adjacent, you just 1 all over 1. Similarly, you do that for sine and cos. You want to get sine 60, you trace it, sine 60, sine is opposite all over hypotenuse. So sine 60 is opposite all over hypotenuse, which is 2. You do the same for this. Now looking at this is how questions are structured in SOLVE. You can be asked to evaluate this. It's very simple. You pick tan 45, tan 30, fix in here and solve. We know that tan 45 is actually opposite adjacent, so here is 1. Similarly, here is 1. Then tan 30 opposite adjacent, you have 1 over root 3. So you have 1 over root 3 here, and here too 1 over root 3. You see, you solve and continue. Here, all you need to do is to use this and this as the lowest common denominator. Then you expand it, you now rationalize, and you simplify this. Express, if this is equal to this, then find x and y. What does that mean? You just make this part of the sword look exactly as this, then you pick out this and add. Simple. Express this in the form this. Rationalize the denominator. If you rationalize the denominator, actually you get it in the form of a is to b. A will completely be an integer, and then this will be the sword. Now prove this if this is this using sword, by sword form, using sword. You can do this also. Remember, we have set of natural numbers and natural numbers, or you say counting number or counting numbers. So just 1, 2, 3, and so on. Then we have set of integers. Set of integers can be negative, 0 can be positive, and so on. We have rational numbers. Rational numbers, we denote them by Q in mathematics, and I told you rational number, you can express it as a form of ratio. So you have maybe P upon Q. Now where P and Q, they belong to the set of integers. Now recall, for the sake of indices and mathematics, Q must not be equal to 0. And I told you any number that is not rational is irrational, and we represent irrational number by I. And so on. When we come to discuss some vocabularies in mathematics, we'll talk about the real numbers, and then we'll talk about the complex numbers also. And if you have any question, you can email me, you can call me, and we can solve all this exercise together. See you next time. Share video, subscribe for your friends, help them eliminate mathphobia. You don't need to be afraid of it. Be solved in